So I wanted to talk about fine-tuning a little bit. The idea of cosmic fine-tuning is of course the claim that the free parameters that are present within our mathematical models of the cosmos, as well as the initial conditions of the expanding spacetime region we call universe, have to fall into a very, very narrow range in order for life to be even possible. Robin Collins briefly lays out the case for fine-tuning as follows.
Scientists have discovered that the universe, its basic structure has to be just right in order for life to occur, particularly intelligent, conscious observers like ourselves. And this fine-tuning problem comes down to basically three different sorts of fine-tuning. First, there's the fine-tuning of the laws of nature. Second is the fine-tuning of what scientists call the constants of physics. And third, the fine-tuning of what they call the initial conditions of the universe. Let me start with the first, the laws of nature. The laws of nature have to be just right in order for life to occur. For example, if you didn't have gravity, a universal attractive force, then matter in the universe would never clump. When the universe blew out in the Big Bang, you would just simply have matter dispersed, never clumping together into planets or stars. If you didn't have the strong nuclear force, the force that holds neutrons and protons together, then all protons would repel each other, and you could not get atoms with greater atomic number than hydrogen. And in that case, unlike what you see in Star Trek, you cannot get complex life out of a hydrogen gas cloud. It doesn't have enough stable complexity. If you didn't have the electromagnetic force, if it just didn't exist, then you wouldn't get complex chemistry. Now, when we look at a lot of laws, like force laws, in fact, most laws have various what they call free parameters. Let me give you an example. Let's look at gravity. There's Newton's law of gravity. It's force equals G times the first mass times the second mass divided by their distance squared. That G is a critical number. If I were to make it 1/2 of what it is right now, you would weigh 1/2 the amount. Then there's the cosmological constant,
which controls the expansion of the universe.
It opposes gravity. In the case of the cosmological constant, there's a natural expected range for it to occur in. Depending on how you calculate this range, it's anywhere from 1 to 10 to the 120th power times what it is now.
Which is a bigger number than every particle in the known universe.
Right, so it's way, way larger than even that. So what you have to have, it has to be adjusted just right. The estimate is it has to be adjusted 1 part in 10 to the 120th power.
Okay, so let's assume all this is true as it probably is. How, if at all, can this be put into the form of an argument for God as a designer of the universe? If we understand theism as a rival to the hypothesis of metaphysical naturalism, the idea that the universe is a closed system not causally affected by anything external to it, then we can compare the two hypotheses. We can ask ourselves, how likely is it that a fine-tuned universe would exist if naturalism was true? If we knew that nature is all there is, would we expect such a fine-tuning as the result of chance? And if we knew that God did exist, would we expect God to create a fine-tuned universe? Given what is called Bayesian confirmation theory, the relation of probabilities between the two hypotheses constitute what we call evidence, favoring one hypothesis over another one. Let T abbreviate theism, N naturalism, and B our background knowledge, while FT abbreviates fine-tuning. Then we can formulate an argument as follows. 1. The probability of fine-tuning, given our background knowledge in conjunction with theism, is larger than the probability of fine-tuning given our background knowledge in conjunction with naturalism. The claim is that we would rather expect fine-tuning given that theism is true than if naturalism is true. Then 2. Fine-tuning is a known fact. 3. Theism and naturalism are roughly equally probable intrinsically. This means that theism and naturalism are somewhat on par initially. One hypothesis is not much more likely initially than the other one. 4. Therefore, all other evidence held equal, T is probably false. So 4 states that if the only evidence we had was fine-tuning, then we should conclude that theism is probably true. So we look at the case of fine-tuning in isolation from all other evidence. Then what to say? Well, we should look at the probability of fine-tuning given our background knowledge in conjunction with theism. How high is it? Do we have good reasons to think it's likely for God to create a fine-tuned cosmos? Well, important is that we don't need the probability of fine-tuning given theism to be especially high. It only needs to be higher than its probability given naturalism. I contend that there is some ground for thinking that if God exists, he would have good reasons to create moral agents, creatures capable of making morally important choices, capable of having meaningful moral and spiritual lives. But there are 2 objections to this. 1. These creatures would not need to be embodied creatures, i.e., partially material entities. And that seems true. God could have created an immaterial angelic realm full of disembodied minds that somehow interact with each other, one knows not how. But surely that doesn't mean he couldn't also create a physical universe. This consideration might lower the probability somewhat, but not all that much. Now the second objection is, God does not need to fine-tune anything. This is an objection one encounters a lot. God could have human beings living on a surface as hot as the sun, as long as he sustains their existence. God could bring forth human life in all circumstances. The point is that the constraints on the existence of life on which fine-tuning is based don't matter for God at all. But this seems confused. Yes, God could have human beings exist in a non-fine-tuned universe by directly intervening constantly in order to sustain their existence. But then, these human beings could impossibly understand the world they inhabit. They could make no rational predictions about the universe they live in. They could form no knowledge about nature, no insight into the way things are. Their whole existence as well as their surroundings would be a complete mystery to them. They would be incapable of forming rational beliefs about the consequences of their actions. They could hardly be responsible moral beings at all. So there are good reasons to think that if God creates embodied beings, then he will also fine-tune an environment for them to live in. And because of this, there are good reasons to believe the probability of God creating a fine-tuned cosmos is not that low. But then what about naturalism? Well, on the face of it, the probability seems low. There are of course so many ways these constants could be arranged that very few of them seem to be able to support life. That's the whole point of the argument. But there is of course the hypothesis of the multiverse, that seeks to render the fine-tuning quite likely given naturalism by supposing that there is a large number of universes with different physical constants and initial conditions, so that somewhere contained within this large ensemble we would expect to find at least some life-permitting universes. So what the naturalist proposes is an additional or auxiliary hypothesis. It's not just that naturalism is true, it's also true that there is a large multiverse containing many universes. In order for this hypothesis to be helpful for the naturalist, there are of course several conditions that have to be met. 1. The ensemble of universes has to be sufficiently large. It won't help naturalism if there are like 8 universes. That won't shift the probability structure significantly. Secondly, the constants and conditions of these universes have to be able to differ significantly. If there is this large ensemble of universes, but their conditions all fall in the life-permitting range, this wouldn't really solve the issue. It would seem they are all fine-tuned. And thirdly, the distribution of constants and conditions has to be roughly homogeneous. If the universes don't vary homogeneously concerning the initial conditions and parameters, then the multiverse hypothesis is of limited value. The initial conditions and parameters have to be real free parameters that are chosen randomly. Otherwise, there would be an additional mechanism in place that might sustain the suspicion of fine-tuning anyway. So there is an overall larger point. We don't know whether or not these facts are true given naturalism. In order for the multiverse hypothesis to help at all, naturalism has to predict such a multiverse all by itself. For suppose naturalism on its own would give us good reason to think that there very likely couldn't be a multiverse. Then of course the multiverse hypothesis would not help the naturalist very much. In order to assess the helpfulness of an auxiliary hypothesis, like the multiverse hypothesis, we would need to consider something like a weighted average. What we want to assess is the probability of fine-tuning given naturalism in conjunction with the multiverse hypothesis. This way, we break the probability down into two summands: the probability of fine-tuning given that a multiverse exists, and add to it the probability of fine-tuning given that a multiverse does not exist. Important is of course the probability of a multiverse existing given naturalism. That's the crux of it. If this probability is low, then it wouldn't help if the hypothesis would, if true, predict a fine-tuned universe. The auxiliary hypothesis itself has to be probable given naturalism. Otherwise, it won't factor into the equation enough to shift the probability significantly. Now granted, there seems to be some evidence for the possibility of a multiverse contained within the best cosmological theories of our time. But they don't tell us enough about the kind of multiverse that is even possible for the multiverse hypothesis to be overly strong. And yet, maybe there is a more fundamental critique of the fine-tuning argument that renders it moot. The problem of normalizability. A probability range is called normalizable if all of its variables eventually sum up to 1. A probability range also needs to obey the principle of indifference, which states that for any probability range, any variable is equally likely as any other. But as Chad McIntosh writes, there is no logical restriction on the strength of the strong nuclear force, the speed of light, or the other parameters in the upward direction. If the probabilities are unbounded, if there are an infinite number of variables in the probability range, there is no way for each variable together to sum up to 1. If they have any sum, it is infinite. This spells disaster for statements of the fine-tuning argument that rely on the claim that it is unlikely for the fundamental constants and laws of nature to fall into a certain probability range. It seems unreasonable to suggest that any one range of values for the constraints is more probable a priori than any other similar range. We have no right to assume that one sort of universe is more probable a priori than any other sort of universe. So one of the issues here is the infinite space of possible values these constants can have. Think of an infinitely large space. And now think of an infinitely large shape contained fully within that infinite range. Now if this shape was the space of life permitting, of fine-tuned universes, and the encompassing space is the space of all possible physical configurations, then in order to derive the probability of a random combination of parameters being life permitting, we would want to know the relation between our shape and the general space. We would want to divide the size of the surface of a sphere by the size of the encompassing plane. But if both are infinite, we would of course run into problems. What is the probability for some constant to fall into some specific range if the range of all possible values is just infinite? Well, this of course invokes fundamental principles of the probability calculus such as finite additivity and countable additivity. Many problems in cosmology have to be solved by dealing with supposedly infinite parameter distributions, so such problems can be solved. And additionally, there have been attempts to restrict the range of parameters in order to keep it finite. But the gist is, the problem of normalizability remains, and as long as it does, one may remain skeptical of the fine-tuning argument.